Okay, sir. Good morning. Good. Okay, sir. Good morning. Okay. Hello. So we are going to have this continuation of our module 5. Although there are some, I need to make a video for this, in order that you can fully understand, the different topics under module 5. And this module 5 will be on next week, so we're a little bit advanced. You are going to finish your module 1 to 4 until this week, and next week is the start of the second quarter. And we have only 3 modules for the second quarter. So thank you for joining us. Is the other one? We will start after maybe 2 to 3 minutes, because we are preparing for the module delivery. It will be on Monday. And I think we don't have class on Monday for Chem 2. So it is because I'm going to deliver modules out of the campus. So we will start our class. That is actually my schedule. So I don't have a schedule in the morning. So for Gen Chem, we have Tuesday to Friday classes. Okay, shall we start? I think some of your classmates will just log in by and by. Okay, may I offer a prayer? Gracious loving Father, we come to you this early morning. We would like to praise your name for giving us another day, and you have given us the opportunity to learn today and to witness your wonderful creation. Thank you, O Lord, for guiding us and for keeping us safe always. Thank you for hearing and answering our prayer. In Jesus' name I pray. Amen. Okay, so good morning. Last meeting, I discussed to you I think, concentration of solution. This is just a continuation, and I have not even uploaded or make any video for that. The last one that I uploaded was about I think that was about the phase changes and phase diagram. So you need to view that one and see all other videos related to that, because you need really the information and to understand what is phase diagram. Of course, when we say phase changes, that's not really difficult to understand. But about phase changes, you need to understand. Now you need knowledge on that, because the coming lessons is related to that topic about phase diagram. Okay, so this morning we will discuss continuation of module 5. Now, continuation of module 5. And we'll be discussing here the Cooligative properties. Now, cooligative. So I already discussed the concentration of solution. So this time is the cooligative properties of solution. What is this all about? No, cooligative. Now our target discussing this module, or the task we need to learn and the skill we need to learn is this one. Describe the effect of concentration on cooligative properties of solution. So we are going to discuss what is cooligative. Maybe it's very new to you, but I think in grade 9 and grade 10, now there's already a topic about cooligative properties. Another is differentiate the cooligative properties of non-electrolyte solutions and electrolyte solutions. So still, we'll be discussing about non-electrolyte and electrolyte solutions. Okay, so first, we're going to define what is cooligative property. Cooligative. In the previous lesson, we discovered that a solution is described in terms of concentration of one or more solutes present in a solution. There are some important physical properties of solutions which are more directly dependent on concentration of solutes. We look at the different concentration units and how they are utilized to determine the desired result. Now, in this lesson, we'll examine the properties that are called cooligative. So what is cooligative now? Cooligative comes from Latin word colligare. Colligare, which means tied. No? So bind, tied together. Properties which mean they depend on the colligative or collective effect of the concentration. So these are the properties that are dependent on the collective. Colligare means, or colligative means collective effect of concentration. These properties include, there are three things that we need, or four rather, we need to discuss. First, we have the vapor pressure lowering. I've already discussed, if you have not seen that video about phase diagram and phase changes, I discussed there the difference between evaporation and vaporization. Because we will be discussing more about vaporization. Although this changes is changing liquid into gas. Parehara ng evaporation o vaporization. But they have slight difference, but they are two. So kung unsay ma-review na to, primero unsay kalainan, ang evaporation, it's a change from liquid to gas, the same as vaporization. Pero the process takes place on the surface, sa ibabaw mo na evaporation. Whereas when we say vaporization, changing liquid into gas, and the process is all throughout the entire body of the system of the liquid. So bisag asa na ay vaporization, o asa man ka nakakita og evaporation nga naa dito sa ubos, di ba? Mag-aso-aso ang liquid change into gas naa gyud sa surface, no? But in vaporization, even on the entire body of the material, it is taking place. Isa pa ka difference between vaporization and evaporation is that the vaporization is took only on the boiling point, no? Boiling point niya. Okay? So, whereas evaporation in all temperatures, bisag unsa nga temperature na evaporation, pero hinahinay lang kung ang temperature, when the temperature is low, there is still evaporation. No, even during cold days, there is still evaporation. Whereas in vaporization, it only starts at the boiling point. Pag start na yung boil, it is the start also of vaporization. Okay? So, mo na yung mga kalainan. Now, today is we're going to study more about vapor pressure. No, vapor pressure. So, likewise, like for example, vapor pressure lowering. Unsaon na to mapaubos na to ang pressure. Now, if you viewed the phase diagram, we know that if we manipulate, like for example, the pressure and maintain the temperature, still we can change the phase of the material, no, the matter. Or we can also change, we can also manipulate the temperature and we let the pressure remain constant. Still, ma-change na to ang phase of what? Phase of the material. Okay, so like for example gani, how this dry ice or carbon dioxide, solid carbon dioxide turn into gas or vapor. Diba? We maintain the pressure but we increase too much the temperature. So, ang solid matter na carbon dioxide, immediately upon introducing a very high temperature, na diretso siya sublimate. No, sublimate from solid. So that is what we call vapor. Vapor. But how could we lower the vapor? Morning pa nato diri karon. Vapor pressure lowering. Okay? So atong tun-an na siya. Okay, so first, so under cooligative properties, there are 3 topics. Morning primero. Now, vapor, what? Vapor pressure lowering. Vapor pressure lowering. So, ato ning kanon. We will discuss more. Dili siya dali sabton, no? Dili siya dali sabton, especially when we are discussing na naarata sa kan. But when you can see the video also, you can really understand more. Okay, first, vapor pressure lowering is a cooligative property of solution. So moingon kita cooligative karon, it is dependent on the collective, no, effect. The vapor pressure of a pure solvent is greater than vapor pressure of a solution. So maingon ta karon unsa nang vapor pressure? We know already that a pressure is a force, no, acting on an area. So man lang gitawag og pressure. That's why we have atmospheric pressure. So that means the atmosphere has force acting, no, on the object, acting on our body. So because we are here in solid earth, so that's why the atmosphere has the force as it acts on this very big container kining atong earth. Murag big container siya. Pareha gyapon nga when you confine a gas inside container, naa gyapon siya ay pressure. Likewise, kanang liquid when it boils and then the liquid phase of that material change into vapor, naa gyapon siya gitawag nato pressure. No, that's why we call it as vapor pressure. And it is under what we call cooligative property of a solution. So here, the vapor pressure of a pure solvent is greater than a solution. Kung ingon tag solvent, pananglitan, water and salt. Moingon kag pressure of water only. Mo na yung gitawag nato vapor pressure of solvent. Pero moingon na po tag greater than the vapor pressure of a solution. Kung na-mix na sila, water and salt, that is now what we call solution. Now, accordingly, the vapor pressure of water is much stronger, now greater than the vapor pressure of water plus salt. Containing a non-volatile liquid. Times sa atong kanon, what is a volatile liquid? Na may highly volatile liquid. Na pananglitan mo yung tag alcohol. Highly volatile na sila. Acetone. Kining uban dili kayo, no? Volatile. That means it takes a long period of time for them to vaporize or to evaporate. Mao nang silang mga non-volatile liquid. Okay? So this lowered vapor pressure leads to boiling point elevation. Again, the lowering of vapor pressure will affect the boiling point of the liquid. Sa to pa kung muubos ang iyang vapor pressure, that means the liquid will increase its boiling point. So this lowered vapor pressure leads to boiling point elevation. Mutaas. Tingala ka nga paan man. Mapataas ang iyang boiling point. When something is volatile, is actually able to evaporate quickly. So something is volatile, kanang mga volatile, mo na siya nga dali ra siya nga mo evaporate. That is the reason. Okay, so what causes vapor pressure lowering? Unsa may what is the cause why the vapor pressure is lowered or can be lowered? Now, some of the surface which is occupied by the solute particles, there is less room for solvent molecule. Gamay na lang especially when there is concentration of or very concentrated solution. So why is it that there is vapor pressure lowering? Ingani ang explanation. Now, in a container, no? So naana dia ang solute and liquid because we're talking about solution. There is less room for solvent molecules. This result in less solvent being able to evaporate. So gamay na pod ang karon kay daghan man ang solute, gamay ang solvent. So what happened? There is less kinsa man ang mag-evaporate di ay. Di ba? It is the solvent. It is not the solute. So when there is less amount of solvent in a solution, there is less solvent turn into vapor. When there is less vapor, there is also what? Less pressure. So ingana ang kwan. The result is less solvent being able to evaporate. The addition of non-volatile solute results in lowering of the vapor pressure. Naapoy uban nga non-volatile. Moingon ganitag non-volatile, dili lagi siya mo evaporate. So the more that the more that the vapor pressure is reduced because there is less liquid that turn into vapor. So that is what we call vapor pressure lowering. Okay. So in a liquid, vapor pressure of a liquid can be lowered by what? By adding non-volatile. Kanang dili makuan. O pananglitan mo ingon ta karon og oil, di ba? Ang oil pila ka semana na ari gyapon ang oil. So by mixing that with mixing that, what happened? There is vapor pressure lowering. Okay, again. So one way how to reduce vapor pressure in liquids. Paasa na to. Okay. So one way to reduce vapor pressure in liquid is adding a non-volatile solute to the liquid which acts as a solvent. Okay? So naana siya. By the way kung maingon gani kag solute, it does not mean nga all solute are all solid. Our example magud permi sa solute is salt and water. Water is solvent. Solute is the salt is the solute. But not all the time that solute is solid. Liquid. It could be gas also. Na inyo nang natun-an sa grade 9, no? So solute not only liquid, not only it could be gas, it could be solid. So ingana ang solute. Okay. But still, how to lower the vapor pressure? There are what we call non-volatile solute. Whether gas siya, whether solid or liquid, there are non-volatile liquid solute. So if you add that one to liquid, which act as solvent, then there is lowering the temperature of the liquid, and therefore the pressure is also reduced. No, so ingana ang kwan. By the way, a little review. How would you know? Nagmix kag duha ka liquid. I don't know if you can answer this. Nagmix kag duha ka liquid, which is solute and which is solvent. What do you think? You are combining two liquids. And then where is the solute? Where is the solvent? How will you know? How will you know? Okay, so this is your in grade 7 lesson. So how would you know? Number 1, the greater amount of liquid is considered as solvent. Mo na siya ang solvent. Dako siya og amount. Dako siya. As long as they are all what? Volatile. Okay, so the more volume of the liquid is considered as the solvent. Okay, I continue now. what happens when vapor pressure is lowered? Unsay mahitabo? What is the effect now when vapor pressure is lowered? Kung ipaubos ang vapor pressure. Vapor pressure lowering is a colligative. Okay. So is a colligative property of solution. So the effect is collective, no? The vapor pressure of pure solvent is greater than the vapor pressure of a solution containing a non-volatile liquid. And what happened? This lowered the pressure that leads to boiling point elevation. So mo nang pirmirong effect, di ba? Kung mag-ubos ang pressure, mo increase ang boiling point. How vapor pressure lowering is related to rise in boiling point? Nganong mo rise man ang boiling point? Ingani. At the boiling point, its vapor pressure is equal to 1 atm. Mo na siyang basihanan nato nga that is atmospheric pressure, 1 atm. No, so that 1 atm is the basis for normal pressure. O ang normal temperature is 0 degrees Celsius. Now, the problem is, why is it that when the pressure is lowered, there is an increase or rise in the boiling point of a solution? Okay, this is the reason. The boiling point of liquid, that means the vapor pressure there is equal to 1 atm. Mo nang giingon ako nga standard pressure. Hence, the vapor pressure of a solution needs a higher temperature to reach 1 atm. So gakinahanglan ka og taas nga temperature aron maabot nimo ang what? Ang pressure kay mubo man siya. Again, unsaon nimo pag-abot sa pressure because this affect kining kuan man god di ba in phase diagram. So naatay katong tripole point dito, and then when the temperature has an effect on the material by increasing or lowering the temperature, likewise the pressure also, even if it's maintained sa ato pa, there is an effect on the material or the object. So kung when there is lower pressure, you need higher temperature aron nga ang material will boil. Okay. So mag-boil na siya, no? So that's why there is an effect on the pressure. So it will not boil unless what? Unless maintain nimo ang temperature. So as you increase the temperature, then mo rise pud ang iyang because again, it is because the pressure is very low, then i-increase niya there is a rise in the boiling point of a solution. Okay? So while lowering vapor pressure is not a colligative property, no, but the vapor pressure of a solvent is not a colligative property. As more solute is dissolved in the solvent, the vapor pressure of different solvents decreases and the change in vapor pressure of the solvent increases. Okay, I have to discuss more about this. Lisod ni siya kayo nga sabto na to, this vapor pressure. No, it's very difficult, especially when we don't apply them. Pag-apply na to, makita na to sa graph, ingani di ay. No? So I'm still discussing piece by piece. And then later on, how do we apply this one? It's the time that you can understand, this is how, no, this is how this specific topic will work, no. So sometimes we cannot understand things, but when we apply, when we see how it is applied, that's the time that we can understand. Okay, so anyway, there are four. That means collective. You cannot understand when it is only one. Collective sila tanan. Okay? What more? We will have number 2. Number 2. What is number 2? This is about may I see my note? Boiling point elevation. Okay, boiling. Okay, so we discussed a while ago that the lower pressure, the lowering of vapor pressure can affect the boiling point, and there is what we call it as boiling point elevation, no? Boiling point elevation. Okay. What causes boiling point elevation? Why is it that there is increase? There is increase in boiling point. Now, going back to our lesson, nganong nga kining atong mga leksyon, they are related from our previous lesson. Going back to the topic intermolecular forces. The greater the intermolecular attraction of the particular liquid, then the higher is the boiling point. Taas ang boiling point. Nga naman, it is because that intermolecular forces will be broken first. No, you need to break the intermolecular forces before evaporation or boiling would takes place. Okay. So karon, we're just talking about vapor pressure karon. We're not talking about intermolecular forces. Though intermolecular forces can increase the boiling point. Now, what causes boiling point elevation based on vapor pressure? Ingani. A solvent's vapor pressure will lower when a solute is added. Again, okay? So there's a solution. We know that solution is made up of solvent and solute. Maybe the solution is unsaturated. Dili pa kaayo siya concentrated, no? Dili pa kaayo saturated. So we call it as unsaturated. What do you mean by unsaturated? That means there is less solute than the amount of solvent. So when you add, you can still add solute. When you add solute on the solution, what happened? There is displacement of solvent molecules of the solute. The molecules of the solvent are being displaced by the solute. Kinahanglan nga naa ang solute, the presence of the solute. For the vapor pressure to equal the atmospheric pressure, a higher temperature is required and a higher boiling point is observed. Okay? So, nga naman, there is now, going back to intermolecular forces, pag naanay daghan nga particles of the solute, then there is now molecular attraction. That's one reason. So, you need a higher temperature to break that again so that boiling or evaporation would start. So that's another reason why there is boiling point elevation. And also, during the time when you add more solute, you are also lowering the vapor pressure. Kay nga nung gilower din mo ang vapor pressure because there is less solvent molecules that would evaporate. Kay imo manggi displace siya, no? So in a solution gamay na lang, no? In a solution gamay na lang ang particles of solvent if you compare it within the solution because you add more solute on the solution. So that there is what we call lowering of vapor pressure and there is in rising of the boiling point, or we call it as boiling point elevation. Okay, now the question, does high boiling point means high vapor pressure? Mao ba na siya? Even in our atmosphere, low pressure area, high pressure area. Sometimes we think nga pag high pressure area, kusog ang hangin. Dili, sayop na siya. When there is low pressure area, the what is that one? The wind, no? Blows very, very strong when there is low pressure area. But when high pressure area, that means good weather condition, no? So the velocity of the wind is not strong when there is high pressure area. How about this one? Does high boiling point mean high vapor pressure? The normal boiling point is the temperature in which the pressure vapor of a liquid becomes equal to 1 atmosphere, 1 atm. If the intermolecular forces are small, or look at again the intermolecular forces, the liquid has a high vapor pressure. More heat will be required to separate the molecules. So the boiling point will be higher. Again, the intermolecular attraction play here. That's why unsa siya kinahanglan og increase nga boiling point, no? Boiling point. So here, more heat will be required to separate the molecules, so the boiling point will be higher. Now, what is now the relationship? What is now the relationship between vapor pressure and boiling point? Unsa may relationship nila? A liquid boils at a temperature at which its vapor pressure is equal to pressure of the gas above it. The lower the pressure of a gas above a liquid, the lower the temperature. Okay? So the lower the pressure, the lower the temperature at which the liquid will boil. So in ana ang iyang relationship. Now, in addition to that, we will have the other topic, the freezing. The freezing. So we have the boiling elevation. We have now the freezing. No, so all of these things actually, if you view the phase diagram, no, you can have there katong, di ba, a phase diagram is divided into 3 segments: the solid, the liquid, and the vapor. And then there is boundary between solid and liquid. There is also boundary between liquid and gas or vapor. And then there is the tripole point where you can find there solid, liquid, and gas. There is also critical point. May critical point that is already between liquid and, pero napag-iuban nga liquid nga mas taas, mahimo silang super critical fluid. That means ang gas pwede nimo siya himuong fluid. Pwede na to siyang i-liquefy. Pwede na to. Gas, ha? They are already gases, but we can liquefy them. Through what? Pag-study na to sa ilang critical point. Because above the critical point, you have there the critical, supercritical fluid. O like for example, nitrogen, pwede nimo na siyang ma-liquefy. O example lang ha, methane. Di ba ang methane gas? So vapor gas. So no, it's a gas, no, methane. So but when it's inside the tank, no, sa kanang mga gasol, it's already LPG. Nganong LPG naman siya liquefied, no, liquefied petroleum gas. Sa ato pa ang gas himo nimong liquid. Now how can you do it? No, through studying their critical point. And manipulating the pressure. So pressure ang imong i-manipulate. And then what happened? Maintaining the pressure or rising the pressure and maintaining the temperature, then you can reach the supercritical, you can turn gases into supercritical fluid. Mauna karon nga naatay mga fiberglass. No? Naatay fiberglass, naatay mga unsa nga mga klase sa mga gamit, mga sa prosthetics, mga even no, there are so many things that were formed, no? It is because of kanang mga Teflon, no? They were created because of that. Okay? May I continue now? Number three, freezing point depression. Depression means lowering. Kaganiha, boiling point elevation, ipataas. This one is freezing, ubos na gyud kaayo, pero i-depress pa gyud nato. Freezing point depression. Okay, now like for example, water. Kanus aman siya start to freeze. Mo freeze, no, freezing point. Di ba ang freezing point niya is lower than 0 degrees. Pag 0 degrees, that means sana siya mo na yung boundary, no? Muubos ana, you are freezing, starts lower than 0 degrees. Okay, but what is freezing point? What is freezing point? Freezing point depression is of a solution is less than the freezing point of the pure solvent. Again, the freezing point of a solution is less than the freezing point of the pure solvent. Again, ang freezing point, no, if you have the solution, you have the salt and water, mo change na siya ang iyang freezing point than pure water. Okay, so layinin nyo ni siya. You try this one if you can do it. Sa inyong refrigerator, mukuha mo ka ng cellophane. You try this at home. Okay, this is very related sa atong topic. And then, di ba gahimo mo og yung kanang ibutang ninyo cellophane bag, butangan ninyo water, ibutang sa refrigerator, and then it turn into ice. Okay? Ang inyong himuon karon, what will you do? Instead of doing that, maghimo gyapon mo. Pero the water you place inside that cellophane bag, daghanan butangan nimo asin. So you are making a solution. Sige, inyo nang kutawon. Like for example, siguro 2 glasses of water. You add 4 to 5 tablespoon of salt. Inyo nang kutawon. Okay? Pag human ninyo kutaw, nga daghan na siya, parat-parat na siya, very concentrated na siya, inyong hiktan. Pag human ninyo hikot, ibutang ninyo sa inyong refrigerator. I am telling you like that, ha? And experiment lang na siya. Again, unsa nga experiment? Okay, cellophane bag, 2 glasses of water, you add 4 to 5 siguro, kung as long as saturated siya, saturated. Unsay saturated? Kanang matunaw pa. Kung natunaw pa yun, dugangi gamay. And then later on, kung di na siya matunaw, nga naanay gamay nga mga particles of solute, then inyong iputos, then place it inside your refrigerator. And what will you do? You observe that kung pariha ba siya nga mag-solidify, nga freezing, freezing man gud atong topic. Pariha ba siya sa water nga pure, nga solvent, nga it's not a solution. O maghimo mo water pure, ibutang dahil dito. Inside the refrigerator. That means pariha kadaghan nga water. The other one with salt. Nahimo siyang salt solution. Whereas the other one, pure water. Okay? So, experiment na to. You try that. Okay. Next. Freezing point. What causes freezing point depression? Why is it that this freezing point will also what? Will be reduced. Naanagin siya sa freezing point, pero paubson pa yun ang iyang freezing point. Freezing point depression. Freezing point depression is the phenomena that describes why adding a solute to a solvent results in the lowering of freezing point of the solvent. Kato na pong solvent. Okay? So, when a substance starts to freeze, the molecules slows down due to the decrease in the temperature, and the intermolecular start to take over. Okay? So, the freezing point of a substance is the temperature at which again, the freezing point of a substance is the temperature at which the solid and liquid forms can coexist. Coexist. Again, duha. Na liquid, na apoy solid. The freezing point of a substance is the temperature at which the solid and the liquid forms can coexist. So not pure nga ice gud sa tanan. There is also liquid at equilibrium. Under these conditions, molecules pass between two phases at equal rates. Mo nang naa siya, it will coexist. Okay? Two phases at equal rates. Because their escaping tendencies from the two phases are identical. Okay, so I hope katong atong experiment inyo tong bantayan, inyo tong after the 24 hours inyong tan-awon. Inyong tan-awon tong inyong experiment, no? Katong gi-instruct nako sa inyo. Okay? Kung mao ba gyud ni siya, kay ingon diri, the freezing point of a substance is the temperature at which solid and liquid forms can coexist indefinitely at equilibrium. Under these conditions, molecules pass between two phases at equal rates. Okay? So, ing-ani siya. So, we're now results of lowering the vapor pressure. We'll have another one. Unsa pa ika-tulo. Vapor, ika-upat na. Osmosis. Okay, so lowering of vapor pressure, and then we have a computation actually on this, kining Van Hoff factor. No, so I'll be discussing this. No, to I am preparing for a video on this so that you can understand this actually. No, so kana siya. So we discussed already the vapor pressure lowering, boiling point elevation. We have also the freezing point depression, and until there, wala ni gapil nila pwede ang osmosis. But anyway, we'll continue. Wala nila gibutang ang osmosis. So we'll have these three only. No, these three only. Okay, it could be. So to summarize, the concentration of solution can be expressed, no, katong mass, mole, fraction, molarity, and molality. Now, vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. But wala gi-take out nila sa atong lesson ang osmotic pressure are cooligative properties of solution. They depend only on the number of solute particles that are present and not on their nature. Now, in electrolyte solution, the interaction between ions leads to formation of ion pairs. And this is one topic I would like to discuss next week. No, it's about the Van Hoff factor. No, so there is a formula and also computation about this. So this is we'll be talking here about electrolyte and non-electrolyte. Kini siya. How important is that in our body? Kana siya. Okay? So I think we are a little bit advanced sa atong module. So kining gidiscuss nako, we will still continue this piece by piece, tagsa-tagsa gyud, no? This coming or next week, starting Tuesday, no? Starting Tuesday. So katong what I discussed today is just an overview, and we are going to study each of them piece by piece, no, to understand more. So what I'm discussing karon, I'm just presenting to you the cooligative properties. So I will include also this osmotic pressure, no. So we will discuss each day one item. So unsa tong mga item dito, like the lowering vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So muna siya atong i-discuss piece by piece next meeting. Okay? So, and I'm also preparing a video for that, no? So that you can understand more. Okay? So, kay sa video man God, makita nimo na yung mga graph, na yung mga table na makita ninyo. So, if you just follow it, then you can understand. Okay? So, Carl, Brian, Kaiser, who else? Thank you for joining our live stream today. And after this, I'll be preparing for the delivery. So thank you very much for joining our live stream today. Now, so next meeting, kining atong i-discuss, mo na i-discuss na to next week. No? It's about Module 5. And we have 2 more modules for the second quarter. No? Ang second quarter na to, we have only 3 modules, including 5, 6, and 7. Okay? So 5, Module 5, Module 6, and Module 7 only. Kaya nga naman, we have so many things to discuss. I know, dili kaayo na ito masabtan pa permiro. No, dili pa kay nato masabtan when the topic is introduced, but little by little, no, if we can extract each of the topic, no, little by little, then we can fully understand, no, what is all about, no, even that colligative property, why they are dependent from each other, no, it's somewhat like not clear to us. Okay, so thank you. We will have our live stream class now will be resumed on Tuesday. Tuesday. Anyway, I have already uploaded now this module 5 in your what? In your Moodle. Okay, so you can open it and answer in advance. So thank you. I'm going to end this live stream now because I'm going to prepare now for the room. Now, dire na mo ikuan in this room, and also the list of the modules as we deliver them to the students who are on MDL. Okay, so thank you very much. Okay. Great is thy faithfulness. Great is thy faithfulness. Thy faithfulness, Lord.